Hello, everyone. How are you doing? If you can hear me, just put a hi and yes in the chat. I can see a lot of people have joined in, and there were a lot of people waiting. I can see that a lot of people are excited for this session because this session is on this very trending thing and very trending topic called as blockchain. And a lot of people I know have a lot of questions regarding what blockchain is, what are smart contracts, what is a decentralized applications, and uh, there's no need to worry because we have an expert today who's going to cover everything. So if you can hear me, just put a yes in the chat. You can see there are a lot of people. Am I audible? Can you all hear me? Great. Cool. Okay. So I think you can also message your friends and also ask them to join the session because this is the first session of learning, about the specific domain as we had promised that we will have 5 sessions on 5 different domains, right? So this is the first session on covering about the blockchain and also about ideation as well about the project as well. So today with us we have Angela Gilhotra, who works as a full stack Web3 developer at Bonfire, and she has vast experience into full stack development as well as blockchain as well. Today she'll be covering about what blockchain is, and we'll cover about what is a smart contract and how you can create it, what is a decentralized application as well. She'll also take your question answer as well, and we'll also give you a short demo as well. So stay till the end of the session, watch the session, put whatever doubts you have, just put it in the comment, and we'll take it at the end of the session. And also you can ask whatever questions you want about ideation as well, and she'll be there to help you out. So I welcome Angela. Um Hi, Angela. How are you?
Hi, I'm good. Thank you for having the session. Thank you for inviting me.
Thank you for coming. It's our honor. It's our pleasure that you have come onto our channel and uh, taken time out of your busy schedule. Even it's Sunday, still you have come over here and trying to impart your knowledge to the students. It's our pleasure. Thank you. And I'll uh, hand over the session to you, and you can get started.
Okay, great. I'll just present my screen. Just a second. Okay. Is my screen visible? I mean, I hope it is. Just do this. Okay, I think, yeah, it is. So yeah, I'll just start with an introduction to blockchain. I mean, this talk is going to be around the theoretical concepts of blockchain. That is how I'm gonna start the discussion, and then towards the end, I'll go through like a brief overview of how you can create your first smart contract and how you can interact with the chain. So I'll mostly, for most part in this demo or in this workshop, I'll be focusing on the Ethereum chain, but there are like other blockchains as well out there as we'll talk about them. So so to start with, what exactly is a blockchain? It's based. So all of these terms are like they sound mouthful, but we'll start with like what the technical definition of a blockchain is, and then I'll go through with like how, oh, in the simplest possible terms, how we can describe what's written on the screen right now. So the very first part is it's a distributed ledger technology, which is supposed to be decentralized and secure. It's ideal for creating it's ideal for creating a ledger that cannot be changed, or the data in it can never be changed, and the data that is stored on this ledger is like it's supposed to be secure. So that is what the essence of a blockchain is, and this is what most of the applications that build on top of blockchain use. And if any application requires a use case like this is where a blockchain would be a perfect fit. So now I'll go through, like, in very simple terms, what it means. So this definition, but explained like in super simple terms. So you can imagine like a notebook on which a bunch of people can write, and once something is written, you cannot change it. Now, each of these words in this definition actually grow up to become like the actual part of blockchain. So, what makes up a blockchain? So, maybe I'll just try. I think, yeah, this is better. So, the first part is what exactly a special kind of notebook can mean. So, when I say a special kind of notebook, it can mean it can mean something like nodes. So in a blockchain, there can be a bunch of people interacting with the network. So it's similar to the internet. So I am on my system right now, and you guys, everyone is on their systems right now, and they're watching this stream happening live. So each of these systems, you can imagine them as being a node, and each of these nodes, when they interact with each other, right now we are interacting with a server that is serving the stream. So now you can imagine when we interact with each other, this is when we are a part of a network that is peer to peer. And blockchain is a peer to peer network. So the special kind of notebook is just the interaction that is happening. It's actually the internet. So any changes that we make in each of these peers database is what the interaction entails. So when I say many people can write on top of this also means that so all of these people have to agree on a way of writing on this system. And again, when I say system, it's actually just the database that each node in the network has on their system. So when all of us agree on a certain way of communicating, this is what a consensus algorithm is. And a consensus algorithm is just like it's a way, it's a protocol that we define, which is specific to a blockchain. So each blockchain has its own protocol, and it has its own consensus algorithm. The next is no one can change it. So when I say no one can change it, this means that um, this actually doesn't mean that no one can change it. It means that it's possible to change it, but the effort involved in changing it is way more than the incentive involved in changing it. So what I mean when I say this is that if I were to change the contents of this notebook or the contents of the ledger, I'd have to run a computation that is so huge, and that would involve so much time, and that would involve so much electricity by my node, that I would rather not change it at all. So the way this happens is that in a blockchain, a bunch of transactions include a note or a summary of the previous transactions that have happened on the chain. And so you can think of this happening for each set of transactions. So this is why it's called a blockchain, because each new block includes like some amount of data that is specific to the previous block. And that is why when you want to change anything, you have to change each and every block that came before it. So yeah, so that, and in the end everyone can read it, just means that it's a public ledger. So that's actually pretty straightforward. Anything that's happening, everyone's involved in it and everyone can read it. So what else we can do with this notebook, or what else we can do with this network, is that you can program the method of writing. So basically, when I say that I can write on this notebook, I can actually program it in a way that if a certain event happens, or anything that happens on a program that I've created, a web application, something causes a write transaction on this network. For example, if a user clicks on this button, transfer X amount of Bitcoin from this address to this address. So this is like programmability. And the way we can do this is because everything is on the internet, and this is like a digital currency. Now, if you think about having like a program that can transfer money from your bank account to someone else's bank account, that is not possible. And we will talk about this actually in the next slide. But this is like a change from traditional finance to crypto finance, or to the Web3 area. And this rule setting that I just talked about, like writing a program, is referred to as smart contracts. So like I mentioned, in traditional finance, you can have an application that, let's say, deducts X amount of money from your account and transfers that amount of money to a certain bank account that you have already that you've already added in your beneficiaries, and that happens at the end of every month. This is also programming. This is also programming that most of us do, and this is only possible because you have actually given all of your money to your bank, and that bank is now handling the wallet application that it has given access to you, and then you are sort of creating this rule inside of your wallet application that is transferring money to the recipient. Like I said, this is only possible because all of your money is in the bank, it's not with you. If a bank declares bankruptcy, your money is gone. In Web3, the only difference is there's no bank. So all of your money is in your wallet application. It's associated with the private key that only you own and only you know about. No one else knows it. And you can create application on top of it that can do stuff like sending X amount of money to the recipient. Now, this is a very simple rule that we can write that at the end of every month, this amount of money goes to the recipient. But you can also create rules which are highly technical, and you can actually create a whole application on top of it. And now, speaking of applications, the you now why exactly would someone want to create an application on a blockchain? So it could either be just for fun, or it could literally be to disrupt the entire financial system. And these are the two applications that did exactly that in the Ethereum ecosystem. So Ethereum is a type of blockchain similar to Bitcoin, similar to Tezos, similar to Solana. So all of these are different kinds of blockchain. And whatever I mentioned, so for example, the consensus algorithm, the nodes, the internet, the ledger, all of that is specific to a single blockchain. These blockchains do not talk with each other yet. I mean, there are projects that are working on making these blockchains talk to each other, but right now there is no way for so see each ecosystem is specific to the specific blockchain. And these two applications are examples of Ethereum blockchain. So on the left is BAYC, which was the Bored Ape Yacht Club, and this was an NFT application. It was just made out of pure fun, and this sort of created this whole ecosystem of art entering into NFTs. So, for example, if any of you already know about how artists are creating like digital versions of their paintings and then selling them as NFTs online, for example, on OpenSea or any other NFT marketplace, um, the boom that happened somehow relates back to the BAYC project. So, like I said, it was out of pure fun, but then this could only happen because of the existence of blockchain. We cannot imagine an application like BAYC or like artists selling their art as NFTs online without blockchain. And then on the right is Uniswap. So Uniswap is actually, if you look at the application, I have not shown the screenshot of what the application looks like, but it's essentially just a way for you to swap your crypto. So let's say if you have an X coin, you want a Y coin against it, you can transfer that X coin to the protocol to Uniswap application, and you get Y coin in return. Now, all of the background thing that is happening is the interesting part, and this is why Uniswap was actually the application that sort of started disrupting traditional finance. So, for example, if you want to convert your currency, any currency that you have right now, you have to go to a centralized exchange. And even with stock markets, if you own any sort of stock, you have to go to a centralized stock exchange. And that is where you agree to exchange money. With Uniswap, everything is decentralized. So, and when I say decentralized, there is no banking system, there is no one authority that is doing it. Uniswap created a way for you to interact with anyone else who has the coin that you are seeking. So this is like the simplest possible way that I can explain it. But if you go deeper into the what the protocol and how the protocol works, like it's actually it's very interesting, and it's also another example of how an application exists only because of blockchain. You cannot imagine an application like this in the Web 2 world. So going ahead, so this was an example of why we need blockchain and why we don't need blockchain. Um, is so the only reason why I like included this slide is because blockchain as a tool is very easy to use in cases where we don't actually need it. For example, there would be applications that do not focus too much on ownership of assets and do not focus too much on security, but let's say they focus on speed. So for example, Twitter, you do not need Twitter on blockchain. I mean, it would actually just be forcing the tool on top of the application. And it's very important to remember this, why we do not need blockchain is because as a tool, it's very easy to just, force it into an application and then sort of like then sort of be sad about the downsides of blockchain as a tool. For example, you cannot expect speed of transactions on any Web3 decentralized application, because a transaction, when it goes through, so when I say transaction, think of it just as an interaction. So any interaction that happens between two nodes, it takes time. And the reason it takes time is because this tool, blockchain as a tool, keeps security as the very first priority. It doesn't keep speed as the priority. And this is why, if your application or whatever you're thinking about, thinking of building in this hackathon, involves, let's say, a lot of speed, or is very very social application, for example Facebook, Twitter, or it involves like you don't mind having less security for the application, then blockchain is definitely not the tool for you. And when you have to decide if the application that you're building might require blockchain or not, just always remember the reason why it came into existence, which is the primary thing is ownership. If you have to emphasize, or if the application needs to emphasize on ownership of assets by the users, that is when you can start thinking about including blockchain. So, like up until now, I have talked about like why blockchain came into existence, and why, like, the two applications that were pretty big in this ecosystem, and why we might or might not need to build on top of it. Now, once that we have decided to build on top of blockchain, only then this part is relevant of the presentation, which is where I'll go about the building blocks of what makes a decentralized application. And also, I'll mostly be focusing on Ethereum because that is the biggest public blockchain out there. I didn't really go into all the different kinds of blockchains because I felt it would because it's kind of like it would get confusing if you think about all of the chains that are out there, because there are way too many. So the easiest way to remember this is that Bitcoin, Ethereum are the biggest blockchains out there right now. Bitcoin is something that is just specific to the currency. It does not have the programmability. It is possible to program applications. So if you remember this slide that I talked about, so it is possible to program an application on top of the Bitcoins sitting in your wallet, but it's not straightforward. But it is straightforward with Ethereum. And that was the whole reason why that chain was created. So it is the largest public blockchain right now, and it is the most easiest to build with. And this is why I'll mostly just be focusing on the terms and the interactions with just Ethereum chain. So yeah, like I said, Ethereum is obviously the biggest building block of building a decentralized application. And when I say Ethereum, it's actually the network that you get access to. The way you get access to this network is via a node. So when I talked about nodes and my system being one node in the network, so think about the internet and think about your system connected to the internet as one node, someone else, your friend's system being connected to the internet, and both of you watching the same let's say website. You are now interacting on the internet. Now imagine these two nodes having their own wallets. Now even forget the wallets. Now imagine these two nodes trying to interact with each other. That is the peer-to-peer sort of interaction that any blockchain network has. And this is what I say when I say Ethereum. So basically, your system being connected to the Ethereum network. I'll actually give very small demo about how you can connect that and what are the tools out there that can help you connect with an Ethereum node. So once you're connected with a node, that is when you can start your interactions with the Ethereum chain, and that is when you can start holding Ether. Ether is the native currency. For example, Bitcoin being the native currency of the Bitcoin blockchain, Ether is the native currency of the Ethereum blockchain. The next is the state. So now that we know how each of the nodes are being interacted with each other, the way they interact is by sending transactions. So again, speaking from internet's analogy, when with the internet you interact with the TCP/IP or the UDP protocol. So that is the language that your system has agreed on has agreed on communicating with. So like right now I'm speaking the English language, the simplest example, and then you guys already know how to understand, and this is how we are able to interact. In a blockchain network, this happens via transactions, and that is the only language that any blockchain network understands. And when I send a transaction, that transaction can hold any kind of data that I wanted to, and that transaction creates a change in the state. That state is the network's state. So when we talked about Ethereum, Ethereum in itself as a network has its own state, and that state is being tampered with transactions. Um, Actually, we'll talk about transactions towards the end of these building blocks list. As you can already see, the last part is transactions. But just remember that transactions is the language that a blockchain network speaks, and transactions change the state. The next is EVM. This is the Ethereum virtual machine. So if you already know Java, Java has a Java virtual machine. It's actually very similar to that, wherein it is like a sandboxed environment inside of each node that that your node can interact with to, let's say, run an execution of a program. And like previously mentioned, a program is just simply put smart contracts. The next is accounts. So when I said that the language this network speaks is transactions, um, the transactions are supposed to have a sender and a receiver. And this sender and receiver is always an account. And this account can either be a personal account, so it can be either an account that I hold, that the private key that I have associates with this account, or it can be a smart contract account. Or like forget smart contract account, it can just be like a simple address that holds some program in it. So that is also something that I'll give a demo for. But for now, you can refer to accounts as um, either an account associated with a human being or an account associated with a program. So these are the two kinds of accounts that you can see on the Ethereum chain. Again, like all of these things could vary very slightly with different kinds of chains that are available there, but this is specific to Ethereum. The next is smart contracts. So, like already mentioned a lot of times in this talk, that smart contracts are basically just you can think of these as self-executable programs. So like I'm pretty sure everyone has already created a program at least once in their life. Let's say even like a printing all the Fibonacci numbers of the sequence, or let's say printing 1 to 10, printing the table of 2, anything of that sort. But execution of that program requires you to run a certain command on your terminal or on your command line window. But imagine like a program that is executable on its own, depending on any external thing that's happening. So it basically keeps looking or keeps it's just stays on its own address until something happens, and that is when it executes. So that is what a smart contract is. It this was a very technical explanation, but essentially it's just a program that is sitting on an address, and any transaction you send on that address is going to cause the smart contract to execute a certain function that you have specified. The next is gas. So, all of this that's happening and everything that we talked about up until now is not for free. So, any transaction that you create on Ethereum network, so Ethereum is a public network. So, this is why any transaction that you create on the network, you have to pay someone something for that transaction to go through. And this is only possible with the concept of gas. So, all of these node operators that we talked about, so let's say my system being connected to the Ethereum network and your system being connected to the Ethereum network, and me being able to send you some Ether, is only possible uh, because I will be able to pay you. So I will be able to pay certain amount as ETH to someone who is already hosting the Ethereum node. And this is how like people are always incentivized to keep the network alive. Otherwise the network won't stay alive. So the next is transactions. And in this, so this small screenshot that I've added here is actually just a way for anyone, like anyone who's building an application and let's say a web application, they can send a transaction. So it's as simple as doing web3.e.send transaction. This is web3 is a JavaScript library. ETH is a certain module inside of that JavaScript library, and send transaction is a function. So that is it. The reason why I added this screenshot is to explain that it's actually very simple. So when I was explaining all of this of what a building block of a decentralized application can be and what a dApp can look like, um, it sort of feels like it would be extremely complicated to send a transaction to the Ethereum network. It's actually not. It's super easy. It's just importing Web3, uh, finding the module, which would be ETH module in our case, and doing the send transaction function. The transaction object includes like a bunch of things, which is the from account, the to account, and any callback that you want to add in there. And a callback can be, let's say, waiting for the transaction to confirm on the network. So, yeah, that is like a conceptual overview of what building blocks of a dApp can look like. So next is building on the blockchain, and this is the sort of like the last and final part of this talk, wherein I'll just go over what a smart contract can look like, the what the functions it can include, and how you can interact with your smart contract. I won't be able to go into details as to building the whole decentralized application, but you guys can always reach out to me and I'll be happy to explain what includes what is involved in creating your own decentralized application and other things. I'll be also very happy to share some resources right after this talk. And also, yeah, happy to take any questions right after this section. So like I said, this is the final section. So yeah, so building your first decentralized application, the things that you would need as a developer. Again, this part, the part that I'm on right now, is very, very developer specific. So this is when, first of all, you have decided that the application that you're building requires a blockchain. And second, you have decided that the application that you're building possibly also requires Ethereum chain. If it doesn't, there are like these steps that I'm talking about would differ very slightly. It won't differ a lot. But yeah, so it's very important to first decide what application you're building, of course. Second, deciding that the application that you're building will involve blockchain in the backend. And also, blockchain will always just be in the backend. It's not a front end thing, it's always backend. So what do you need? So first of all, your application needs to have a node access, and this node access can be anything like, so when I say node, it's basically any system that has all of the transactions that have ever happened on the Ethereum chain or on the Bitcoin chain or on the Tezos chain, so any chain. So if I have a server sitting right now with me, which has all of the data of the Ethereum chain, and it also has an EVM running with it. So, like I said, EVM is the sandbox environment that sort of adds transactions to a new block, and this is how a transaction is being created and added to the chain. So this an access to a node like this is required for your application to start interacting with the Ethereum chain. The next is a smart contract file. So smart contract is what will define um, how you can create a transaction on the chain. And then that is a simple JavaScript file. This is just for front end, and this is how you can maybe read from the chain or write to the chain. So I'll just Oops, I'm so sorry. So I'll go over just a second. So I'll open this remix.ethereum.org. This is the website. Like this is the first step into creating your, let's say, first smart contract on the Ethereum chain. So I'll also go over what this IDE is, what it does, and we'll also go over first smart contract that you can build using this website. So all you have to do, even if you're following with me right now in this workshop, all you have to do is open remix.ethereum.org. This is the website. It's actually just remove this. It's just this remix.ethereum.org. And the first thing that you'll notice here is like the homepage. It has a bunch of things written. You can basically just ignore all of it and see on the left, there's a contracts folder. In the left, on the contracts folder, you'll be able to see one underscore storage.sol. And this is an example of a smart contract. It's as simple as that. Nothing scary over here. So um, what this contract does is you actually might won't be able to see this public. I think this is what the default smart contract is going to look like when you open remix.ethereum.org. And in here, any contract basically starts with a contract name, the storage, and it has like the curly braces and a bunch of functions, and that is it. So if you have ever written a ever written a program in JavaScript, or actually in any language, we always sort of create like a main function which has a bunch of functions in it, which is the function we actually execute. So imagine that main function as being the contract over here, and a contract can always include functions or variables, and that is it. It cannot really include any like any other programs running inside of it. You can call other contracts inside of this contract, but overall the structure of a contract looks like just a bunch of variables and a bunch of functions. It's super simple that way. And then in this contract, what this contract is supposed to do and what we can make out from what it's written is that there's a function called store and there's a function called retrieve. So store is basically just taking number as the parameter, and it's changing this variable that this contract includes. And the retrieve is basically just retrieving the number. And yeah, that is it. So it's very easy that way. And then this line, if you're looking at this line, it's basically just telling the compiler that the version that you want to use to compile the smart contract, it has to be greater than zero point 0.7 and less than zero point 0.9. And when I say compiler, it's actually sending this contract, converting it into bytecode, and sending it to the EVM. And if you remember what we talked about, the EVM is actually just the Ethereum virtual machine. It is taking the bytecode, it's processing it, and then it's putting it out on the blockchain. The cool thing about Remix is that it gives you a blockchain in memory. So when you open remix.ethereum.org, it actually creates a very lightweight version of the blockchain inside of your browser window so that you can do stuff like create your contract, test it out, and then maybe put it on the Ethereum blockchain or Google Cloud blockchain node or any other node that's out there that you want to use. So the first step, like after you create your contract, is to compile it. And also one more thing that I forgot about discussing is that the language that we are using in this contract is called Solidity. And there are other languages as well, actually, if you see on the homepage. So these, I don't think they mention it anymore, which is sad, but okay. So there are other languages as well that can be used to create your smart contract. One of them is Viper, and the other is Solidity. And there are other new languages also being built right now. But the most famous one and the most used one right now is Solidity to create your smart contracts on the Ethereum chain. So yeah, so back to the contract. Once we have created our contract and once we are happy with how it looks, we can compile the contract. It's basically just clicking a button on the Remix IDE, and it gives you like a bunch of options over here. So ABI and bytecode are the two main important ones. Bytecode is, you can actually just click on it and see what it looks like. I mean, if I just paste it away, it's actually just a bunch of numbers. I mean, as you can see. I'm sorry, I don't think you'll be able to see, but yeah, this over here, this is what the bytecode looks like. This is what the chain or the Ethereum virtual machine takes and processes. The next is deploying the smart contract. So if I go over here in this tab, it's the last one is deploy and run transactions. So if you see over here the environment, so actually I think I can zoom in. Okay, great. So the environment is basically the network. So when I said Ethereum network or the remix creating like in memory blockchain for you, that's the environment. So in the environment you can also change it. You can change it to so merge London Berlin. All of these are just different names of the network, so don't get confused by these. You can always just use the default one to test out contracts, or you can use let's say you can use the injected provider. For this you would need MetaMask, or for this you would need an extension that connects your browser to the Ethereum chain. But for now I think like just using remix vm merge is like the best possible way that you can, you know, create your first very own smart contract. The cool thing about remixes in memory blockchain is that it gives you a bunch of accounts you can test with, and all of these have 100 ether that you can, you know, use to send transactions, receive transactions, do whatever with it. You can ignore the gas limit for now, but but it's actually related to the gas that we discussed in the presentation, and it involves like how much gas you can send to the contract and how much gas you can use to create transactions. The last part is the contract. So it's actually the contract that we just compiled, and you can just click deploy over here. And once I click deploy, this is what happens over here. So if you zoom in, the VM is that the message is coming from the virtual machine, and it says the transaction mined and execution succeeded. And the from transaction is the address that was used to send the transaction or send the deploy, which is this account that we saw over here. And then the two is basically just the contract that we talked about. And then the gas used, you can ignore all of these other parts. These can get a little bit confusing. But overall, this is what has happened right now, that we have created the contract and we have clicked deploy, and the deploy has happened on the in-memory blockchain, and it happened via the virtual machine. So all of this we already discussed. One another thing that I would like to go through before ending this talk is how you can use JavaScript to do what we just did, which would explain the programmability of the smart contracts and the interaction of your application with the smart contracts. So the reason why I say interaction is that these smart contracts live on the Ethereum chain, but these can be interacted with via JavaScript, which is like the language that you will be using on your web application. Also, one thing to note here is that in my experience, it has been the easiest to interact using the JavaScript language on JavaScript language on the web application for me to be able to interact with the smart contracts. The other language is Python, but there aren't like any more languages that are being supported by the third party libraries that can help you interact with the Ethereum chain. So for example, if you're using Rust or if you're using any other language, you'll always need like a thin layer or a thin wrapper on top of the web application that you're building for you to be able to interact with the Ethereum chain using JavaScript or Python. So, okay, so the last part is how JavaScript can be used to interact with what we just created or what we just did. So I'm going to go over here, and this is also something that you can see in your IDE right now if you've opened it. So if you go inside the scripts folder, you'll be able to see deploy with ethers and deploy with Web3. So if you open deploy with ethers, I mean, it's pretty simple. It's pretty straightforward. You'll be able to see how this script is using Ether's library to deploy the contract that you just created, and it's going to give you the contract. Oh, sorry. Okay, so it's going to give you the contract address that was deployed on the chain. So, for example, if I run it right now, okay, okay. So now that I've executed this script, what it did for me was it created. So it didn't. So this response is from the previous transaction that we did. This is from the script that we just ran. So it says deploying storage because that is what we have programmed it to do, deploying storage, and the address is this. So you remember when we talked about accounts in the building blocks? And I said that how each account is either associated with a human being or it is associated with a smart contract. So this address, so an address like this always refers to an account. So this address is associated with a program or a smart contract. And this is where our storage contract lives on right now. If you see over here, it is actually importing deploy from Ether's library. And it's basically just Ethers, the NPM package that you can just do npmi Ethers. And then this is the deploy function that they have created, which is sort of deploying the contract. So you see the deploying storage actually came from here, and it's picking the artifacts. You can ignore this part for now. And it's basically just doing what it's supposed to do. It's picking the contract, creating the contract object, and then deploying it. One another thing that we can do is I'll actually just create a script so that I can demo how you can interact with the contract. And again, using Remix because it's the easiest to do. But remember that all of these things that we did, from creating a storage contract, deploying with Ethers, like importing the Ethers library, and then now what we're about to do, all of this can be done like in your local environment as well. You do not need Remix for it. The only reason I'm using Remix is for demonstration purposes, and also because I feel like it's the easiest to get started with. So again, to start, maybe I'll just, again, so let's just pick this part from here. I'm going to import Ethers, and let's just pick this whole function from here just so we get a head start. And then I'm going to create a contract object. So let's say I call my contract object as contract, and let's call this, actually, wait, I'll just maybe remove this. Let's just remove this as well. And let's just do console log contract. So we'll be able to see what contract looks like. And when I want to create a new contract object, the minimum that I need to create a contract and for me to be able to interact with it I'll just start with ABI and address. Okay, so this is the most minimum that I need for my JavaScript or for my Ethers package to understand where the contract lives and for it to be able to fetch it from the network and for it to give me like all of the possible functions that I can interact with. So I'll just create an ABI over here. So if you remember when we deployed the contract, we got the ABI over here and the bytecode. We do not need bytecode for anything like ever. This is just for the EVM, but we do need the ABI. So let's just pick the ABI from here. We go back to our test to app, and we can ignore this. So I've included ABI. It's just like a pasted thing. So I just picked it, pasted it over here. I'm also going to create a const address. And if you remember, the address is what we got over here. So these two combine. Okay. So these two, the address and the ABI, combine to form like the unique identity of our contract. And what we'll do now is we'll create the contract object. So let's do ethers.contract, and that is it. If I remember it correctly, I think it's ABI and address. But if not, it's going to throw an error and we'll know what to correct. But anyway, so this is what the script looks like. And if we run it, Oh yeah, okay. So it's actually the address and the API. So the way I got to know it was because this error that was thrown. So it's always the address first and the API. This is also something that you can just check in Ether's libraries documentation. So it should be easier to look into. And there we go. So this is what our script returned. All of this is just like all of the different possible ways that we can interact with our contract. So it's actually, I mean, it's basically just demonstrating that our contract, which we deployed on a blockchain, is accessible to us via this simple TypeScript file or a JavaScript file. The process is going to be exactly same with Python as well. I mean, obviously the language would change, but overall, just remember that these are the two languages that are easier to interact with. Other languages, you would have to probably create a thin wrapper to interact with the chain. Um, but yeah, that is pretty much it. And this is all that I had to share today. And I would actually be very curious if you guys have any questions. And I'm going to stop sharing now.
Hi, Angela. Uh,
Hey.
there are a couple of questions. So there aren't a lot of questions, but there are a couple of questions regarding. So another question is from Satyansh Srivastava. He's asking what is a ledger, and this question has been asked by many people over here. What is a ledger?
Okay. Okay, so a ledger is, like I said, so if you remember in the second explanation that I gave, when I said like a blockchain is basically just a notebook that everyone can write on, you can think of that notebook as the ledger. So, and when I say ledger, it's essentially, so imagine like your system connected to the internet or connected to the Ethereum network. So your system is going to have EVM as the minimum requirement for it to be able to understand what the Ethereum network is doing. And that system will always have a database inside of it. The database is going to store all of the transactions that have happened on the network. So that is what the ledger is, a database of all of the transactions that have happened on the Ethereum network. And an Ethereum node or a blockchain node will always have a ledger associated with it. For you to be able to create an application on top of it, you do not need an EVM or a ledger. You basically just need one access to a blockchain node. And that node, for example, can be provided by the Google blockchain node thing. Actually, it can be provided by any third party application that are hosting nodes. And one of the examples is the blockchain node engine. So I'll just maybe paste this link in the live chat. I'm not sure how I can paste it, but maybe I'll just send it to you and maybe you can paste it in the public chat. But
Sure,
I
sure.
just sent it. Yeah.
So there's another question from RJ, and the question is how efficient blockchain can be for identity management.
It's actually a very interesting question because there are a lot of projects that are building on top of identity management with blockchain. Blockchain as a protocol does not provide identity management in itself. So for like you won't get identity management out of the box with blockchain, but you can use the tamper proof nature of the database, and you can use the fact that a private that an account, it can be connected with a private key as like identity management system. So for example, you can create a system, let's say you can create a server that accepts a transaction only if it has been signed by a private key. So that way, you would always know that a private key associated with an account is always connected with a human, and that is how you can sign them in. So, for example, a lot of the decentralized application, like let's say Uniswap, uses Web3 authentication to sign users in. So that is how identity management is being taken care of. The way it's actually a lot easier in the Web3 a system as compared to in Web 2. So, for example, in Web 2, you have single sign on with Google or single sign on with Facebook. But in Web 3, you can have sign on with MetaMask or sign on with your private key. So, you as a developer only have to verify if a particular string that is being signed by a private key is associated with an address or not. So that is how you can sign people in, and that is how identity management can be taken care of in the application that you're building.
Great, great. There is another question related to ledger. So there are two parts of the question. So I'll just put it on the screen. So the first is there any method of recovery if a powerful enough party takes over the ledger? And what he
Mhm.
means by this is, I assume if a single party owns 51% of the ledger, then they become the main chain, and any changes they made to the chain would override the previous chain, right?
Mhm. Yeah, so actually, I mean, it cannot override the previous changes. Anyone with 51% power. So, I would like to explain it for others as well. So, when we say ownership of 51% of the ledger, it's actually not, so it's actually ownership of more than 51% of the nodes in the network. It's not exactly ledger because ledger is associated with the database. um, so if so for example, if there are three people including you and I in an Ethereum network, and if I own like more than 50% of the nodes, I can always make sure that only the transactions that I want are included in the blockchain. And if I am including those, you even though you are a minority party, you won't be able to add any more transactions other than the ones that I want to be added. So this cannot be changed, obviously, because that is how a blockchain is coded. But this is only a downside in the blockchains that have proof of work as the consensus algorithm, as opposed to any other consensus algorithm out there. So like I said, the consensus algorithm, or the way uh, each node is interacting with each other, is specific to each and every chain. So right now, on this date, Ethereum is using proof of stake as the consensus algorithm, and this problem is actually not available in Ethereum at all. It's actually a problem in Bitcoin chain. But even then, the more number of nodes are there are participating in the network, the more difficult it is for to reach 51% of the strength in the network. So this is why in the Bitcoin ecosystem, if you are a Bitcoin like holder, or if you are someone who wants to operate a node on the Bitcoin chain, it's actually suggested that you run your own node, even if you own like a small part of Bitcoin as a currency, because it's very important to have more number of nodes so that it's more difficult to reach 51% powerfulness. But with Ethereum, it's actually quite simple because it runs on proof of stake, and there is no such problem exists in that chain. And this is again, it would differ for each and every chain out there. For example, Tezos uses its own consensus algorithm, and all of them have their own downsides and upsides.
Great, great. Um, Thank you, Angela, for the session. I don't see any other questions. Um,
Okay.
and I think you've answered a lot of questions as well. And there are these repeated same questions as well. So, yeah,
Mhm.
thank you for the session. It was actually very knowledgeable. I was hearing you and got to know a lot of things about blockchain. Since I'm keenly interested in learning blockchain, because I myself am a full stack developer. I never did
Okay.
anything related to blockchain, but got to learn a lot about blockchain. That was a great session. Thank you again for the session, and I hope you had a great time over here.
I did. And thank you so much for inviting me. There's just one last thing that I would want to mention. I saw like one question in the chat when I was scrolling through that
Mhm.
how is GCP related with this session? So I just want to mention that when I said that the building blocks that are required to create your first decentralized application, you need access to one of the nodes that are that are associated with a particular chain that you want to deploy on. So, for example, if you want to create your application on Ethereum, you would need access to a node that is an Ethereum node. So GCP provides a blockchain node. You would just need like a link to connect with the GCP node. So for example, you would just need so what we just did in Remix, you create your contract, you deploy it on Google's cloud node, and then you sort of interact with Google's cloud node. So that is how GCP can be used in it. The link that I shared with you in the private chat and that you can probably share with everyone in the public chat is what will guide you into creating, into fetching that link. You'll have to fill up a form, but that's pretty straightforward. So all of this can be done using GCP. Yeah, that's the link. Okay.
Great.
But yeah, that is all. Thank you so much.
Thank you, Angela. So that's it, guys, from today's session. Again, a reminder that there are four more sessions on the in the next 4 days. So covering different domains, like the remaining domains like fintech, health tech, agrotech. So subscribe to the channel so that you do not miss out on the notification of the live session. And if you have more doubts, you can put your doubts on Discord. I think most of you might be on Discord. If you are not there on Discord, just join our Discord channel. And there are mentors, there are TAs who will basically help you out in resolving all your questions related to your projects. So you can ask a doubt as well, and do not forget again to subscribe to the channel so that you do not miss out any updates on the live session that we have. So yeah, thank you again for joining, and we'll see you tomorrow. Bye bye.